Hi, we're going to take a few minutes and look at the ambiguous case for the law of signs. And the ambiguous case happens when you are given side-side angle information. So that's two sides and the non-included angle in a triangle. The reason this is an ambiguous case is because two sides and an angle do not always mean that there is definitely a triangle. The other pieces of information that you've seen in law of signs and that you will see in law of cosines do automatically give you a triangle, but not this one. So first we're going to talk about the steps to deciding if there is a triangle, and if there is, how many there might be. So the first step is to drop a perpendicular between the given sides. So I've already done this in this picture. My given sides were A and B, and I dropped this perpendicular and I called it H. The second thing is to find the value of H, and we'll find the value of H using trig. Notice here we have A, and we'll be given this side, so you would say that the sine of A is H over B, and then solve for H. Notice that H is a leg of two right triangles. The right triangle on the left has this value for the hypotenuse, and the triangle on the right has this value for a hypotenuse. So if H is larger than A or B, there is no triangle, because H is a leg and A and B are hypotenuses. So since those are the hypotenuse of right triangles where H is the leg, A and B must be larger. So if H is bigger than either one of them, there is no triangle. If H equals A or B, there is one triangle, and it's a right triangle. If H is less than A and B both, then there is at least one triangle. So that's step 2, is to find H, and you need H to be less than both A and B to guarantee that there is one triangle. If H is bigger than either one of these sides, then there is not a triangle. If H equals one of those sides, then it's a right triangle. So our third step is to determine the number of triangles. To do that, we're going to use the angle here, marked with a question mark. If this unknown angle is opposite the smaller of the two sides that are given, then there is one triangle. So I'm going to say if the question mark is opposite the smaller of the two sides, there is one triangle. And the reason for that is that we have a rule in geometry that says the smallest angle is opposite the shortest side, and the larger angle is opposite the longer side. So if this angle is opposite the smaller of the two sides, then that means it must be acute. Likewise, if our missing angle is opposite the larger of the two sides, there are two triangles. In one, the question mark will be an acute angle, and in the other, the question mark will be an obtuse angle. So again, to determine the number of triangles, we look at this missing angle here. If it's opposite the smaller of these two triangles, of these two sides, then there's only one triangle. If it's opposite the larger of these two numbers, then there are two triangles, one acute and one obtuse. Then our step 4 would be to solve for the triangles. Okay, so if you need to stop and write that down, you can pause it, but we're going to do a few examples. It's my little scratch paper there. Okay, so let's look at this problem here. We have a 30-degree angle and a side of 6 and a side of 2. So the first thing we need to do is drop our perpendicular between the two sides. I know that's not quite straight, and call it H. The next thing that we need to do is find the value of H, and we'll do it using this triangle here. So we will say that the sine of 30 degrees is H over 6. So H is 6 sine 30, which means that H is 3. Now we need to compare H to our two sides. Remember, in order for there to be a triangle, H has to be equal to or smaller than both. But notice that here, H is bigger than 2. So since H is bigger than 2, there is no triangle. And we're done with that problem. Here we have another triangle. We have a side of 314, a side of 205, and an angle of 35.4. So our first step is to drop the perpendicular between the two sides and call it H. Next, we need to find the value of H. So H is, well, let's start the other way. The sine of 35.4 is H over 205. So H is 205 sine 35.4. So H is approximately, let me do this with my calculator, 118.8 degrees. So when I compare H with both of these, H is less than 314 and H is less than 205. Since H is less than both of the sides, there is at least one triangle. Now we need to figure out exactly how many triangles there are. To do that, we're going to look at this angle here. This angle is opposite 205, which is smaller than 314. Since this angle is opposite the smaller of these two, there is only one triangle, and in that triangle, this angle will be acute. So we can solve for that. We would set up our base ratio of sine 35.4 over 314 equals the sine of our question mark over 205. So once we cross multiply and all that, we're going to get that our question mark is what? The inverse sine of 205 sine 35.4 over 314. So let's see, the inverse sine of 205 Sine 35.4 over 314. 22.2 degrees. Once I have that, I can find this other angle up here using just that the angles of a triangle have to add up to be 180 degrees. So 180 minus the 35.4 I was given minus the 22.2 I found gives me 122.4 for that missing angle up top, X. And then if I want to find this third side here, we'll call it Y. We would start with our base ratio again, sine 35.4 over 314 equals the sine of 122.4 over Y. And when you cross multiply and solve, Y is 314 sine 122.4 over the sine of 35.4, which is 314 sine 122.4 divided by the sine of 35.4. 457.7, which at first seems really large, but remember this is 205 and this is 314, so it's not out of the ordinary for this to be 457.7. And then notice that this is the largest side and it is opposite the largest angle here, which is that X that we found to be 122.4. So let's look at one more. Here we have sides of 54 and 62 with an angle of 40. So again, our first thing we need to do is drop a perpendicular and label it H. Then we're going to find H. Again, let's start with the sine of 40 is H over 62. So H is 62 sine 40, which is 39.9. So since H is smaller than both of these sides, we are guaranteed to have at least one triangle. So now we need to look at how many there are. To do that, we're going to look at this unknown angle. This unknown angle is opposite the larger of these two sides, which means that there are two triangles possible here. One where this angle is acute and one where this angle is obtuse. Since it's opposite the largest side, the only way we're going to get an obtuse angle is opposite the largest side. So let's see, let's write that out. Since this is opposite the larger side, there are two triangles. So let's see, the first triangle is where our question mark is acute. And we're going to solve that the exact same way that we solved the last one. So we will start with our base ratio, which will be the sine of 40 over 54 is the sine of our question mark angle over 62. Once we cross multiply and divide, we're going to have that our question mark angle is the inverse sine of 62 sine 40 divided by 54. So let's see, the 62 sine 40 divided by 54. The inverse sine of that is 47.6 degrees. So then we can find this third angle by doing 180 minus the 40 degrees they gave me, minus the 47.6 I just found, 92.4 degrees. And then I can find this third side, which we can call y, by setting up the sine of 40 over 54 is the sine of 92.4 that we just found for this angle over y. And once we cross multiply and solve, we're going to have that y is 54 sine 92.4 over the sine of 40. 54 sine 92.4 divided by the sine of 40. Y is 83.9, which makes sense again that y is the longest side because x is the largest angle. Now we need to talk about how to find the second triangle. Remember, we said that there were two triangles because our unknown angle was opposite the longer of the two sides. So we found the first triangle where our question mark angle was acute. Now we need to find when our question mark angle is obtuse. So the first thing we do to find the obtuse angle is going to be 180 minus the acute measure that we found up here. So that's going to be 180 minus 47.6. So 132.4 is the measure of our obtuse question mark angle. Then I need to find my x value for this new triangle. So I'm going to do 180 minus the 40 degrees they gave me at first, minus this 132.4 I found. And I get 7.6 degrees. And then lastly, I need to find the side y, which I'll do the same way I did before. The sine of 40 over 54 is now the sine of 7.6 over y. Let's just work to the right here since we're almost out of paper. So y is 54 sine 7.6 over the sine of 40. Let's see, 54 sine 7.6 over the sine of 40 is about 11.1. So let's look quickly back at our original here. To solve the ambiguous case, we first drop a perpendicular between our given sides and call it h, wherever they are. Then we have to find h. In order for there to be a triangle, in most cases, h is going to be less than both a and b. Remember, if h should equal a or b, then you have one right triangle. To determine the number of triangles, we look at this missing angle here. If the missing angle is opposite the smaller of these two sides, there is only one triangle. If this missing angle is opposite the larger of these two sides, then there are two triangles possible. One in which this angle is acute, one in which this angle is obtuse. To find the triangle where this angle is acute, you just use law of sines normally. To find the obtuse triangle, you do 180 minus the acute angle of this and then use the rest of the information in your triangle to find the missing pieces. I hope this helps.